Hi, welcome to the maths class. Today we are going to start a new chapter, lines and angles. All right, we'll wait for 2 minutes for the participants to join and then we'll get started. All right, so let's get started. In this chapter about lines and angles, we'll recap first our basics of what is a line, segment, ray, angles, and then we'll learn about linear pairs, adjacent angles, linear pair angles, and then finally vertically opposite angles. Then in the later classes, we will learn about parallel intersecting lines, parallel lines, various questions related to parallel lines. And then in the last, we'll learn about triangles, angle sum property, and exterior angle property of triangles. All right. So before we get started, for this class, I have prepared the desktop, which will show you various angles in colors, and we'll try to use that so that we can visualize. See, all these lines and angles, you have to visualize the angle. You have to visualize how it is rotating, turning, and then you will understand that very well. All right. So give me a moment, and I'll share the screen with you. All right, so there we go. So this is what we'll cover as part of this chapter. Okay, so let's start with what is line segment, or array. Okay, so when we say line, what does it come to your mind? A straight line, right? So what is then line segment? Yeah, there is difference between line and line segment, and let's see that. So when I say a line is an infinite collections of points in a straight line. Whenever we say line in geometry, it's always a straight line. So it's infinite collection of points, which means, you remember in Euclid, also in the previous chapter of Euclid algorithms, it was said that a line can be extended indefinitely on both sides. So how do we typically draw a line? We draw a line like this. Notice there are two arrows at the end, which means lines can extend indefinitely on both sides. So that is how we define a line. How do we write a line? So we put the two tick points on that, A and B, and we write the line like this, AB, and on top we put a line, a bar here, which has two arrows. Okay, so that is how you write a line. So which is a very standard notation for writing line. So what is a line segment? So line segment means what? It's a piece. So which means if I cut a piece out of a line, then that piece is called line segment, which means it is a fixed length. Its ends are fixed. It cannot move. As in, it cannot be extended indefinitely because we have cut a piece of it. So that is why it's called line segment, because it's a piece of line. So how do we represent? We represent by a dot at the end of these lines, which very clearly means that it cannot be extended in any which way. All right. And how do we represent? If the two ends are called A and B, then we write A and B with a vertical bar, with a horizontal bar on top, like this. And remember, the arrows are not there. So if you see this, there are no arrows here. And if you see this end, there are no arrows, which means it's a fixed length segment. Then what is ray? We have used the word ray, right? Sun rays, light rays. That is the clue. See, line has both ends extended forever up to infinity. Line segment has both ends fixed. So ray is one end is fixed and the one end is extendable to infinity. So rays are like this. See, why do we call sun rays? See, when you have sun and you have rays coming out of it, right? So you see, all rays are starting from sun and going out, isn't it? So it is fixed at this end. It is starting from sun and it is going. So all these are called sun rays. Or if you have a torch, have you seen a torch? Correct? So light emanates out of it, starts from the bulb and goes. So these are called rays. See, one end is fixed and one end has arrow. Okay? So that is called ray. And how do you represent ray? Let's mark 2 points. One end as A and one tick on the other side B. So we say 1 AB and on top one dimensional arrow. So which says it is a ray because it can go extend only in one direction. Okay? So that is basic definition of rays. Now our next is, let's take 3 points. A, B, C. Any 3 points on a plane, XY plane, on a flat surface. And if I can draw a line passing through all the 3 points, if I can draw a line passing through all the 3 points, then the points A, B, C are called collinear points. What is collinear points? Basically, linear means line, and collinear means they exist on the same line. Collinear points. So all the 3 points are on the same line. And let's take another set of 3 points, PQR. All right. So do you think we can draw a line through all the 3 points? A straight line? Let's try. So if I try between P and Q, then R is off. If I draw another line with connecting P and R, then Q is off. And if I draw another line connecting Q and R, then P is off. So there is no way I can draw a line in which all the 3 points will be on the same line. So we can say PQR are non-collinear points. Okay? Fairly clear? If we can draw a line through 3 points, of all the 3 points lie on the same straight line, then they are called collinear points. Whereas in the second example, PQR, you will see all 3 points don't fall on the same line. That is why they are called non-collinear points. These are the words you have to remember because they will be used, and at that time, if you have not understood them what they are, it will be difficult for you to apply or understand in the question. That is why you have studied all of this in the previous classes, but this is important for you to recap. Okay. So now let's move ahead from lines and go to angles. So whenever you have 2 lines or 2 rays coming out of a common point, they form what is called an angle. Correct? So this is the vertex. These are called arms. Okay? And this is called your angle. Correct? So now how do we measure angles? Or you can measure using a protractor, right? In your geometry box, you have a D-like instrument, right? You can align the cross on that with the vertex, and one of the lines, 0-degree lines with one arm, and the other arm will tell you the angle. You can measure angles. All right. So there are 2 angles given on the screen. What is the difference between them? Yeah, the second one looks like 90-degree angle, right? So this is less than 90-degree. So, do you know what is the name of angles which are less than 90-degree? They're called acute angles. Acute angle. So, acute angles are more than 0-degree and less than. So, if this is X, this angle measure is X degrees. So, X is more than 0 and less than 90 degree. So that is our acute angle. All right. So this one looks like 90 degree. So what is this angle called? Right angle. So this is called right angle. So angle is, if this is your angle, x is 90 degrees. All right. So you remember that, right? Acute angle, right angle. So what is the next angle? More than 90 degree. What is that angle called? Correct. Obtuse angle. So it's typically like this. See, visually you can see it is more than 90 degree, correct? So if this is the angle, then this angle is more than 90 degree, but it should be less than 180 degree. So what are such angles called? Obtuse angle. So obtuse angle is less than. Obtuse angle is more than 90 and less than 180. So what is 180 degree then? 180 degree means straight line, flat line, right? So this kind of angle. You see here, if this is the center and if this is x degree, this is equal to 180 degree. So this is called straight angle, straight line angle. Okay, right angle, obtuse angle, straight line angle, or straight angle. Straight angle is also fine. Okay. So straight angle means 180 degree. All right. So what if the angle is more than 180 degree? What do you call? You have to remember, it is called reflex angle. So if it is more than 180 and less than 360, so if this is x degree angle, then x is more than 180 degree and less than more than 180 degree and less than 360 degree, then it is called reflex angle. All right. So you have studied all this for all along, right? 6th standard, 7th standard, 8th standard, 9th. Now in 9th we are revising again. Okay. So that's a reflex angle. So this was the reflex angle, right? We said this is x degrees and it's 180, more than 180 and less than 360. So what if I complete the red arm all the way and make it back to the same position? That is like this. See, I have turned the red side all the way from here back almost to the same point. So this is now complete circle. What is such an angle called? What is this angle? If this is angle 60. So this is x equal to 360 degrees. So this is called complete angle. What is it called? Complete angle. So at this point, the whole thing is completed. This was anyways your reflex angle. Reflex angle. All right. So will you remember that? That this is a complete angle because the angle mark has turned completely. It has come all the way here. So that is also sometimes referred as complete angle. So that is quick dump about angles. All right. Hey, you guys are so late.
Yes, sir.
You are so late.
No, sir. Sir, internet problem.
Internet problem. All right, I think your still video is frozen. Are you able to see? Okay, so that's the complete angle. So I don't know till what point you have seen. I've shown all this, right? So did you see this part? Okay. So this is your acute angle, which is less than 90 degree. Then you have 90 degree, which is called right angle. And then you have more than 90 degree, which is called obtuse angle. Okay, so that's your obtuse angle. Then you have straight angle, which is 180 degrees. And then if you have more than 180 and less than 360, it is called reflex angle. All right, so if we complete the full circle, then it is called full complete angle. So that's 360 degrees. Okay, so now we will continue ahead. Now, if two angles add up to right angle, which means these two both have to be acutes because they have to be less than 90 degree, right? So if two angles add up to 90 degree, they are called complementary angles. So that is angle A plus angle B should be 90 degree. Okay? Fairly simple, right? You have studied this in the past also. This is just revising that so that we will use all these terms in this chapter going forward. So that is A plus B is complementary. Okay. Next comes supplementary angles. So what is supplementary? If you have two angles and they add up to 180 degree, then they are called supplementary angles. The pair of angles is called supplementary. So that is angle A plus angle B is 180 degree. Now next comes adjacent angles. So if you have two angles like this, that is angle, this blue angle you see and this angle. So remember, first let's look at the blue angle. For the blue angle, let me change the color pen and write. So we are talking about blue angle. So this is the vertex, correct? This is the arm and this is the arm. And this is the angle, right? And let's look at the maroon one. So for maroon, this is the vertex. This is the arm. And this is another arm. All right. So if you, two angles will be called adjacent only if, see, they have the common vertex and they have one arm which is common to both. Correct? Then the two angles, 1 and 2, are called adjacent angles. So whenever you have this kind of situation, that they share the common vertex and one common arm, then it is called adjacent angles. And it's very important to understand that there has to be a common arm. Now there is one more condition. That the non-common arms, which is this and this, should be on opposite sides of the common arm. So when we say these three conditions are met, then we have, then the pair of angles are called adjacent angles. So what are they? First, there should be a common vertex. So in this case, the point B. There should be a common arm BD, which is this side. The BD is common to both 1 and 2. So ABD is 2 and this is 1, right? So they have a common arm. And non-common arms, which is this and this, should be on either side. That is very important, because if I draw angles differently and there is this non-common arms are not on both sides, then they will not be called adjacent. And we are going to use this definition again and again. So adjacent means neighbors. See, whenever we have neighbors, one wall is common with them, right? And you live on one side of the wall and the other guy lives on the other side of the wall. Same case, adjacent arm means neighbor angles, neighborhood angles. There is a common wall and one side, one arm is on the other side, the other arm is on the opposite side. And whenever you have that kind of situation, then the two angles are called adjacent angles. So think of adjacent angles as your neighbors, your neighbor angles. All right. Is that okay? Clear? So that is called adjacent angles. And we are going to use that again and again throughout our discussion in further slides. So if there are two adjacent angles, then we can always say that the angle formed by non-common arms, that is angle ABC, will be equal to sum of the two adjacent angles. All right, which simply means that this angle will be sum of this plus this, two angles. So this is your angle 2 and this is your 1. Correct? You can see that. So this angle, this whole angle, 3 is 2 plus 1. Okay? So that is the power of adjacent angles. That you can take two adjacent angles and add them. It will become a resultant angle. And we are going to use this again and again and again. Let me show you now how we are going to use this. So now, let's take pair of adjacent angles. Now I have taken pair of adjacent angles, which means they have a common arm here. This is the common arm, BD. They have a common vertex B, and the non-common are on the opposite sides of the common. So these angles are adjacent angles. And if these adjacent angles form a straight line, or the non-common arms form a straight line, then the adjacent angles are called linear pair of angles. So if ABC becomes straight line, then so these are angles. Angle 1 and angle 2 are called linear pair of angles. Okay, so when it says, it is already given. We are given that 1 and 2 are adjacent. So that is given to us. So if 1 and 2 are adjacent and ABC becomes a straight line, then 1 and 2 are called linear pair of angles. But you know the property of adjacent angles, that we can add angle 1 and angle 2. So here it is saying angle 1 and angle 2 is the complete angle. That is this angle. And this is as straight line angle, which means it is 180 degree. So angle ABC plus angle ABD, angle ABD. ABD is angle 2 and this is angle 1. That will be equal to 180 degree. So sometimes we say linear pair of angles are also supplementary, which means they will add up to 180 degree. So adjacent angles, a pair of adjacent angles will become linear pair only if they add up to 180 degree. Okay? And you know, any pair of angles which add up to 180 degree are also called supplementary. So linear pair of angles is also supplementary. Now you understand the connection between all three? All right. So very simple. Adjacent angles are neighbor angles. Two neighbor angles, when they add up to become a straight line, then it is called linear pair of angles. And you know straight line is 180 degree. So which means linear pair of angles are supplementary. Okay. Is that clear? Confusing? Should I do it on board? Your connection seems to be very bad. All right. So if you have understood this, I'll go ahead and let's take another set of linear pair of angles and see what happens. So we say that if two axioms come out of it, if a ray stands on a line, so what we can say is if a ray stands on a line, then the sum of two adjacent angles is 180 degree. Sum of two adjacent, suppose 1 and 2 are adjacent. So you are given a ray stands on a line. So you are given ABC is a line. This is given. Right? So if ABC is a line, then angle 1 plus angle 2 will be equal to 180 degree. So that is your one axiom. So for every axiom, there is a reverse also. What is that? That if sum of two adjacents is 180 degree, then the non-common arms of the angles form a straight line. And that is what we saw in the previous slide. See here, that if two angles add up to 180 degree, then ABC is a line. ABC becomes a straight line. Correct? So both ways it's true. If it is a straight line, then the angles will add up to 180 degree. Because they're called linear, and those adjacent angles are called linear pair of angles. All right? So if you have understood, can you raise your hand if your audio is not transmitting? Your video seems to be frozen. Okay. So now, what if there are more than one angles on a straight line? Take a case like this. See, I have many angles on one side of the straight line. So that is 1, 2, 3. 3 angles on one side of the straight line. So what will be 1 plus 2 plus 3? Angle 1 plus angle 2 plus angle 3. See, all the angles 1, 2 and 3 add together still form the straight angle. See, this is this. And you know what is straight angle? That is 180 degree. So all these adjacent angles put together will be equal to 180 degrees. Correct? No doubt about that, right? It is given. What is given? It is given that ABC is a straight line. All right. So if ABC is a straight line, then angle 1 plus angle 2 plus angle 3 will be equal to 180 degrees. So if I have 5 angles instead of 3, let's say if I have a situation like this, where I have many angles, all right, it really doesn't matter. All angles put together will be still 180 degree. So we can simply say sum of all angles on either side of the straight line will be 180 degrees. Correct? Is that okay? Clear? Because remember, angle at any point on a straight line is always 180 degree on one side. Okay, on a straight line. So when I say straight line, which means if this is a line, this is a point, and we said this angle is 180. Now it really doesn't matter how many pieces you cut into. This is cut into 3 pieces. This is cut into many pieces. So angle on a straight line will always be 180 degree. Now, angles at a vertex. You remember when we were learning the angles, we had a angle in which we turned all the way right. That was called complete angle. So how much was complete angle? 360 degrees. Complete angle was 360 degree. So if I have now a situation like this, that there are some 5 rays coming out of it from a single point origin or a vertex, common vertex in different directions. So there are 5 different angles. 1, 2, 3, 4, 5. 5 different angles. So what will be the sum of all these 5 angles? Sorry, how much? Yeah, 360 degrees. Because it really doesn't matter. We have divided that full complete angle into 5 pieces. You can divide into any number of pieces, non-equal pieces. So all of these angles, 1, 2, 3, 4, 5 will be 360. If there were like 9 rays emitting out of it, it really doesn't matter. All of them will add still to 360 degree. Because angle at any given point, the complete angle is 360 degrees. So sum of all angles on a vertex or a point will always be 360 degree. Remember that? Okay. So line on a angle on a straight line will be always 180. Angle at a point, vertex, will always be, complete angle will be 360 degrees. So let's go ahead. Now let's take 2 straight lines. I take one line called ABC, and you see one angle of 180 degree on one side. And I have another line called PQR with 1 degree. What happens if I make these 2 lines intersect each other at a common point? Let's say the common point is I will intersect ABC and PQR at a common point B and Q, and I'll rename that O. Let's see what I'm saying. So I'll cross these 2 lines. Okay, see, they're crossing at O, which was the point B and Q, right? So I just put a new name, AO. So these are 2 straight lines. It's given, and they intersect at each other. So what happens when they intersect? There are many angles formed at vertex O. So look at the vertex O. See, there is angle 1, there is this angle 2, there is this angle 3, there is this angle 4. So at the point of intersection, this is the point of intersection, right? We can call this as point of intersection. So at a point of intersection, there are 4 angles created. All right, but you were already told, right, that AOC and POR are straight lines. And I have named them 1, 2, 3, 4. So how many linear pair of angles do you see? Actually, there are 2 straight lines. So there should be, we will take one by one. All right, so let's take the first one. If we take AOC, so we take this line. I am taking this line, AOC. See? So there is this angle, and there is this angle. What are these? So you see, 2 and 3 make one linear pair, this angle, and this is made by 1 and 4. So when we look at line AOC, I see two linear pairs, correct? 2 and 3 and 1 and 4. Now let's take the second line. If I take this line, so again I see two linear pairs. One is this, which is 1 and 2, and the second one is this, 3 and 4. Correct? When there are two lines, one on the side and one on the bottom side. So I can say for POR, 1 and 2 form a linear pair and 3 and 4 form a linear pair. Okay? So that is pretty clear, right? So if there are two straight lines, one angle above and one angle below. So there are one pair above and one pair below. And likewise for the other line, again we have one pair above and one pair below. So now I'll erase this markings and you can see for yourself very easily. All right, see, now it's pretty clear, right? If you take line AOC, consider the line. So 2 and 3 and 1 and 4. So now you got 4 linear pairs, 2 for each line. Now let's look at this and see, we'll take angle by angle and find how many adjacent angles are here. That's pretty interesting. So I've copied the same diagram here. All right. And I'll take the first angle. You remember adjacent lines? There should be a common neighbor angles. So let's find how many neighbor angles of 1 are here. So I'm looking at, first let's look at this angle. So angle 1. So how many neighbors of angle 1 are here? We can immediately see this angle 2 is the neighbor, right? It has this common wall and it's here. So angle 2 is neighbor and angle 4 is also neighbor. This side, there is this common wall and there is this common wall. So 2 and 4 are neighbors of 1. How about angle 3? Is it adjacent to 1? No. See, only 2 and 4 are adjacent to 1. So when I say for 1, neighbors are, this is adjacent and this is adjacent. So 2 and 4 are adjacents of 1. Adjacent of 1. So 3 is called opposite, or it's called vertically opposite of angle 1. See, it is not neighbor, it is opposite to angle 1. You are understanding this? So adjacents of angle 1 are 2 and 4. So vertically opposite of angle 1 is 3. Fairly okay? Now I want you to look at angle 3. Whom are we looking at? Angle 3. Can you tell me neighbors of angle 3? One is this side. So this is adjacent. And one is this side. So this is adjacent. So 2 and 4 are adjacent to 3. So what is 1? 1 is vertically opposite to angle 3. Got it? So 3 is vertically opposite to angle 1 and 1 is vertically opposite to angle 3. So we have a pair, 1 and 3, 3 and 1. They are called pair of vertically opposite angles. Got it? Once again, we started with angle 1. First we found neighbors of angle 1, which are angle 2 and 4. So angle 3 was vertically opposite to 1. Then now we started looking from angle 3. We found 2 and 4 are adjacent to angle 3 and 1 is vertically opposite to angle 1. Angle 3. So we can say 1 and 3 are in a pair. Opposite of 3 is 1 and opposite of 1 is 3. So 1 and 3 form a pair of vertically opposite angles. Okay. Likewise, we can next take 2. So for angle 2, who are the adjacent angles? 1 and 3. So 4 is vertically opposite. And for 4, 1 and 3 are adjacent angles and angle 2 is vertically opposite. So again, same condition. So we find 2 and 4 are pair of vertically opposite angles. So now I got 2 pair of vertically opposite angles. Correct? 1 and 3 and 2 and 4. So in the previous slide we saw we had 4 pairs of linear, 4 linear pairs. Now I have 2 vertically opposite angles. Let's see what does all of this mean. What can we say about pair of vertically opposite angles? So here is this again, right? 1 and 3 and 2 and 4. So that's pretty straightforward now. So remember, 1 plus 2 is equal to 180 degree. Why? Linear pair. Remember the linear pair, right? 1 and 2 are on one side of line POR. Line POR. Okay. And 2 and 3 is 180 degree. Why? Again, line AOC. So these are all linear pair. So this was linear pair for, and this one was linear pair. Remember, we had 4 linear pairs. So these are one of those linear pairs. Pair of line AOC. Now what does this equation tell? Something plus angle 2 is 180. Something plus angle 2 is 180. So what does this mean? This means 1 should be same as 3. So 1 should be equal to 3. Correct? Because both of them added with angle 2 gives you 180. Which means they have to be equal. Right? Arithmetically. Now let's take another pairs. See, for POR, we had taken 1 and 2 first time, these two. Now we will take this 2. 3 and 4. Oh, sorry. 2 and 3. We have taken now line for AOC. So we have taken linear pair for line AOC. 2 and 3. This. Okay. And we have taken 4 and 3. That is this. POR. Line POR. And you see here again, angle 2 plus angle 3 is 180. Angle 4 plus angle 3 is 180. So same thing added to angle 3 gives you 180. Which means 2 and 4 should be equal. But what were 1 and 3 and 2 and 4? See, 1 and 3 are here. They were the pair. They were the first pair of, they are the pair of vertically opposite angles. And same here. This was the pair, the second one. So what did we find? Oh, the pair of vertically opposite angles are equal. Isn't it? So that is our theorem. If two lines intersect each other, then the vertically opposite angles are equal. And we could prove it using just the linear pairs. First time, see, first time I took these two angles. This, 1 and 2, and 3 and 2. And second time, we took the red dot arrows. And we could simply prove that they are equal. So pair of vertically opposite angles are always equal. This is also called vertically opposite angles theorem. All right, and we are going to use this again and again throughout our class. Okay. All right. So let's see if we can solve some questions. So there are lines PQ and RS intersect each other at 0.5:7. PQ and RS. PQ and RS, and they intersect at O. So if POR, angle POR, this angle, ratio of POR to ROQ, this angle, is 5:7. Find on the angles. So we are basically supposed to find all the angles. So before we do anything, let's mark our angles. Okay. So this is angle 1, this is angle 2, this is angle 3, this is angle 4. Because it's much easier to work when we mark those angles. All right. Now, what is it given? POR. That is angle POR is angle 1 is to ratio of angle 1 is to ROQ, angle 2 is same as 5:7. All right. So whenever ratio is given, you can multiply it with some common factor. So we can assume angle 1 is 5x and angle 2 is 7x. We just multiply with some constant. Multiply with constant. Okay. So now you already know from the vertically opposite angle theorem that angle 1 is equal to angle 3 is equal to 5x, because angle 1, or let's write like this, angle 1 is 5x, which is equal to angle 3, and angle 2 is equal to 7x, which is same as angle 4. And you know, right? Or let's write like this. Sorry about that. So angle 1 and 2. Now you are given POQ is a line, right? Then from linear pair, we have angle 1 plus angle 2 is equal to 180 degree. Correct? One side of the angle. Now 1 is 5x plus 7x equals to 180. 180, which is 12x equal to 180 degrees. So x equal to 180 degrees divided by 12. And if you do it, you will get 15 degrees. So angle 1 is 5x, which is 5 into 15 is 75 degrees. And angle 2 is 7x, 7 into 15. 7 into 15 is 105 degrees. So now you know this is 75 degree, this is 30 degree. Now you know vertically opposite angles are equal. So which means angle 3 is equal to angle 1, which is equal to 75 degree, and angle 4 is equal to angle 2 is equal to 105 degree. So we got all our 4 angles. That is angle 1 equal to angle 3 equal to 70. This is our answer. All right. So that's how you can solve. Now let's look at this. AB and CD intersect at O. So AB and CD. Where did so AB and CD and AOC AB CD intersect at O. So AOC plus BOE. BOD is 40°. So there is some angle E. E. So AOC plus BOE. Okay, some angle E it is given. So let's name our angles. Angle 1, angle 1, angle 2, angle 3, angle 4. And this is angle 5. COE is reflex. Okay, and BOE is this angle. So we are supposed to find BOE and COE. And let's mark it. So you are given AOC. AOC, that is angle 1, plus BOE. BOE is angle 3 plus angle 4 is 70°. Angle 4 is 40°. BOD is 40°. Okay, so what are we supposed to find? We are supposed to find BOE. I think the diagram is missing. So what we'll do is I'll get the diagram from the book and then we will mark the angles. Then it is pretty straightforward. Okay. So we'll solve this in our next class. So let's do a quick recap. What did we finally do cover in today's class? So first we went over line segment rays. We went over various angles. We saw what is acute angle, right angle, obtuse, straight, reflex, and complete angles. So basically starting from less than 90, 90, then between 90 and 180, then 180°. Then reflex was between 180 and 360. And when we completed 360, it was called complete angle. Then we learned about adjacent angles. Adjacent means neighbor angles. There should be a common arm. And the non-common arm should be on the either side of the common. Correct? Otherwise, they are not called adjacent. Then we went over definition of complementary angles and supplementary angles. And then we learned about two theorems. One was linear pair of angles theorem, which says that if you have angles on one side of the line, they will always be 180°. Sum of all angles on a point or a vertex will always be 360°. And then in the last, we also learned that if we have two intersecting lines, then the pair of vertically opposite angles will always be equal. All right. So with that, we conclude this class, and the next class we'll take up these two questions with the diagrams and we'll solve them. All right. So you go over your book, and if you have any questions, feel free to ask me in the next class. All right. Thank you so much. Bye.